Right, 2014 question on functions. I actually don't have the question here. G is the function, g of x is x minus 1, where x is an element of R. Find the value of each of the following, okay? So it was somewhat similar to the 2015 question 4 that we just did a few minutes ago. So when we have g of x being equal to x minus 1, and they ask us to calculate g of 3, you can see that x is being replaced by 3. Okay, so replace x with 3 in the actual function itself then. So I get 3 minus 1 being equal to 2. And in the same way, if I have to find g of minus 2, replace x with minus 2, just like it was replaced here. And you'll get minus 2 minus 1 being equal to minus 3. Okay, and that's all there is to those type of questions once you understand what the language is. Okay, there's another question just while I think of it, and I hope it doesn't confuse you. If you're asked to find this one. Okay, what is the difference? Okay, well remember our function g of x is equal to x minus 1. So they've now told me that the answer to it is 3. Not that x is 3, otherwise they'd have had written it as g of 3. They've instead said that this was equal to 3. And they're asking you to find the x value that makes this equal to 3. Okay, so x's to one side, numbers to the other, or plus 1 to both sides. So x is equal to 4. Okay, so does that work? If we put 4 into this, do I get the answer of that's equal to 3? Well, 4 minus 1 is indeed equal to 3. So g of x equal to 3 is different to g of 3. Okay, so try not to mix those two up. Okay, f is the function 2x squared minus x minus 6. Using the same axes and scales, draw the graphs of the function y is equal to f of x and y is equal to g of x in the domain minus 2 is less than or equal to x is less than or equal to 3. Okay, so let's do this. Let's draw our table. So there's our x values. And we were told to do our x values from minus 2 to 3. So minus 2, minus 1, 0, 1, 2, and 3. Our function, let's do g of x first. So g of x is equal to x minus 1. And let's calculate our y values. So this is the same as x of minus 2, just like it is here. So I would expect to get minus 3 for my answer. So what you do is anywhere you see x, you replace it with minus 2. So that you get minus 2 minus 1. So we get minus 3. Okay, so that line there is exactly what you did here. Let's do it for minus 1. So anywhere there's x, you can replace it with minus 1. So minus 1 minus 1, and we get minus 2. X now takes on the value 0, so replace x with 0. So we get 0 minus 1. And you can see this minus 1 stays constant all the way down. That doesn't change. So we're going to get minus 1. X in this one is 1, so replace x with 1. And we get 1 minus 1, so it's 0. This one, x becomes 2. And in this one, x becomes 3. You can, of course, put this into your calculator using mode setup, picking the table option. Your start is minus 2, your end is 3, and you're going up in steps of 1. Of course, you can do that, no problem at all. Okay, so that's one of the graphs we have to do. We also have to do f of x. So draw yourself another table. and same x values. -2, -1, 0, 1, 2, 3. Except this time my function is 2x squared minus x minus 6, and that's going to be my y values. So just like before, anywhere there's x in the first one, I'm going to replace it with -2. So it'll have to go in here because there's an x, and it'll also have to go in here. So he becomes 2 bracket -2 squared minus bracket -2 minus 6. Lots of minuses there, so easy to make a mistake. So I'm just putting this into my calculator. So -2 bracket squared minus bracket -2 minus 6. So I have got the answer of 4 for that one. Okay, so I'm going to put this in using mode setup. So number 3 for my table, f of x is equal to 2 red x squared minus x minus 6. So 2x squared minus x minus 6 equals start -2 equals end 3 equals, and go up in steps of 1. Okay, so I always put in one line to show the corrector of my paper that I know what I'm doing, and I did indeed get 4 for that on the calculator. I then got -3 for -1. At 0 I got -6. At 1 I got -5. When x was 2 I got 0, and when x is 3 I get 9. Okay, so now I want to draw my graph. Okay, so the x-axis is easy enough. I go from -2 to 3, so that's okay. I'm looking at my y values and I'm seeing, well, how low and high do I have to go in him? So the biggest number is 9, so I have to go up to 9. And then what's my smallest number? And it'll be a -1, -2, -3, -6. So I have to go from 9 to -6. Okay, so let's draw my graph. I have to go from 9 to -6. Okay, so a little bit more on the top. Okay, let's put in my numbers. I'm wondering, can I go up in 2 boxes? 1, 2, 3, 4, 5, 6, 7. No. So I'll have to go up in 1 box. So I'm going to go up in 1.5. And you keep the same width all the way up. So that would be important. So 1, 2, 3, 4, 5, 6, 7, 8, and I have to go up 1 more. There's my 9. And I have to come down to -6. Okay, and then on my x-axis, I'm going from -2 to 3. And the gap can be bigger on the x-axis. The x-axis and the y-axis can actually be different, as I'm showing you here. X-axis and my y-axis. Okay, and then you plot your points. So I'm going to plot g of x in blue, because I've done it in blue. So my couples, -2, -3. So -2, -3. -1, -2, all the way up. So 0, -1, 1, 0. You can see the line coming. 2 up to 1, and 3, 2. So let's join them together. Okay, and that is the line. What was the letter? G of x. Okay, switch to purple and let's plot this one, our f of x. So my couples, -2, 4. So -2 up to 4. my next one, -1, -3. -1, -3. Okay, that's a bit of a drop. 0, -6. 1, -5. 1, -5. 2, 0. And 3 all the way up to 9. Okay, and of course, this is an ax squared plus bx plus c, which is the normal pattern for a quadratic. Okay, so I'm not surprised at all to see my u coming up there. Okay, so let's try drawing him together in as smooth a hand as you can, because he's a curve now rather than a straight line. So turn there up to 5. I'm just turning around my pad here now. That's what the noise is. And then up to 9 as best you can. And label him f of x. Okay, so that is on the same axis and scales, draw the function. Okay, and not in this question, but you sometimes get questions on this. So using the graph, let me just change color. So from the graph, where is g of x equal to f of x? Okay, that's one question that gets asked. And that is maths language for where do the two lines intersect? Where are they equal to each other? Okay, so it's here. And it's here. So you write down as best you can those coordinates, so -1, -2 type thing. And it's a bit like 2.2, 2.1, comma 1, something like that, or 2, 1. Okay, and if it was a more accurately drawn thing rather than me trying to draw it digitally on a screen, you'd probably get whole numbers for it. So it's that maths language that I kind of want you to understand, okay? Or where do the graphs intersect with each other? And that's the normal question you get asked when you have to plot two graphs on the one plane. Okay.